Well, it is an ideal heat engine cycle by a French physicist, Sadi Carnot. It utilizes heat energy transferring from a heat source to a heat sink. In addition, it composed of four reversible processes. The reversible process means direction can be returned to its original position. Also, it uses ideal gas as its working medium. And note that this is a perfect engine. No friction between piston and cylinder walls, and no heat transfer between the surroundings and your system. So now for the first process, process 1 to 2. This process is called isothermal expansion. Isothermal in thermodynamics means no change in temperature, or in other words, temperature is constant or not changing within this process. So what happens here is that the heat energy from the heat source is transferred into the ideal gas. As a result, the gas expands, which then increases the volume and decreasing the pressure. Next, process 2 to 3, which is called an adiabatic expansion. Adiabatic in thermodynamics means that there is no heat transfer between surroundings and your system, or to put simply, all change in temperature is contained within a system, which as a result making the entropy zero. On this process, our volume increases and pressure decreases. Third process is the isothermal compression. So by compression, it means volume is decreased and as a result, pressure increases. On this process, heat energy from the gas is transferred into the heat sink. And finally, the last process. The last process is called the adiabatic compression. Since it's an adiabatic, all change in temperature is contained within a system, and our entropy is zero. Also, since this is compression, it means our volume decreases while our pressure increases. So that's it. That makes it a cycle. So now let me ask you this. Why Carnot cycle is the most efficient cycle? Mhm. Well, it's because Carnot cycle is a perfect engine. The processes are reversible, working medium is an ideal gas, and of course, the thermal capacity of heat source and heat sink is infinite, which makes no reduction to both during heat transfer, as we have observed, right? But for all those same reasons, it makes this cycle impossible to operate in our real world, as obviously those things don't exist. Well, of course, we should not forget that it contributed so much today. In fact, it is a model of our car engines like Otto and diesel cycle.